Well, let's take a look at this question here. A closed rectangular storage box is to be constructed with a volume of 4,500 cubic centimeters. The length of the base should be 3 times the width. The material for the top costs 7 cents or $0.07 per centimeter squared, and the material for the sides and the base costs 5 cents or $0.05 per centimeter squared. So we have two different costs for two different materials. Determine the minimum cost of building the box. So first off, we need to figure out what are we asked to optimize in this question. And like all of these cost questions, we are asked to find the minimum cost. Okay, so this is the thing that we want to optimize. We're going to need an equation for the cost of building this box. Now, the cost is going to depend on the amount of materials that we need, and we're given costs for the material, and the amount of material that we need is going to depend on the surface area. So we don't want an expression or an equation for the surface area. We want an equation for the cost, which is going to incorporate it's going to incorporate finding the surface area of the various sides. Now, first of all, what are we given in the question here? We are given that the volume is 4,500. So we are going to want to come up with an expression for the volume of our box. And that volume, try that again, that volume is going to be length times width times height. Now, we are told that the length of the base is 3 times the width. So we can add that to our diagram here. Length is 3w. And in this volume expression, we can just replace our length with 3w times width times height, or 3w squared times h. And we know that that is going to be equal to 4,500. 3w squared. Okay. Now that equation is going to help us later on when we are working with our cost equation. So let's just go ahead and try to figure out what our cost equation is going to look like. Now, what do they tell us about the costs? Well, we've got two different materials. Okay, we've got a material for the top, which costs 7 cents per centimeter squared. Okay, that's just for the top. And then the rest of it, the sides and the base, costs 5 cents per centimeter squared. So when we're setting up our equation for the cost, we want to divide it up in terms of those two materials. Okay, so our first material cost is that 7 cents, and it represents the cost of the top. If we add to this the cost of the base and the sides, that'll give us the total cost. Okay? So we want to break it up like that, because we know that the cost of the top is going to be that $0.07 per centimeter squared times the area of the top, and that the cost for the base and the sides is going to be that 0.05 centimeter squared per centimeter squared times the area of the base and the sides. So this is where our expressions for the area are going to come in. So 0.07 times, what is the expression for the area of the top? Well, the top and the base are going to be the same. They're going to be width times length, or in this case, width times 3 times width. So that's going to be 3w squared plus our 0.05, doesn't change, area of our base and area of our sides. Well, our base is going to be, again, 3w squared plus, let's see, what do we have in terms of sides? Well, we have 4 sides here, but they're kind of different from each other. So our two sides on our end, let's change colors here to something nice here. Our two ends, so that's this here and this front side here, those are going to be width times height, so WH. Same thing over here, WH. So we've got two of those, so that's going to add a factor of 2WH. Now our front and our back, I guess, so this side sort of back here and this side here are going to have an area of 3W times H, okay, because the length here is 3W and the height is H. So 3H, same thing at the back here, 3WH. So we have two of those, so 3WH and 3WH gives us a total of 6WH. And that's our expression for the cost. Now, this can be simplified a little bit here. So at the beginning here, let's do some multiplication. So 0.07 times 3 is going to give us 0.21 W squared plus, in here, let's collect our like terms before we do our multiplication. So that's going to be 3W squared. 2WH plus 6WH is going to give us 8WH. And now we can do our multiplication. 0.21 W squared plus, this will be 0.15 W squared and plus 0.4 WH. And now we have some more like terms to collect. 0.21 plus 0.15 is going to give us 0.36 W squared plus 0.4 WH. So that's our expression for the cost, as simplified as much as we can. So we're going to want to take the derivative of this, set it equal to 0, and then solve for one of our dimensions. Now, before we can do that, right now we have this is a function of two variables. So we want to write it as a function of one variable. So we have to solve for h in terms of w. And to do that, we're going to come back up to this volume equation that we were working with before. So we'll take this and we're going to solve it for h. 4,500 divided by 3 is going to be 1,500. Divide by the w squared, divided by w squared. And we're going to take this expression and we're going to sub it in for h in our cost equation down below. So this is going to become 0.36 w squared plus 0.4 w times 1,500 divided by w squared. And we can do a little bit more simplification before we take our derivative here. 0.36 w squared. So if we multiply the 0.4 by the 1,500, we are going to get 600. W times w squared, we can cancel out a w there and there, and we can write this as w to the negative 1. Okay, now let's take our derivative. So we'll just say c primed here. Bringing down the 2, we're going to get 0.72 w. Bringing down the negative 1, negative 600 w to the negative 2. And we want to set that equal to 0 and solve. So let's see, let's go 0.72 w. Let's bring the 600 over to the other side. So 600, and instead of w to the negative 2, we'll write it as divided by w squared. Then we can cross multiply by the w squared to get w cubed, and divide the 600 by 0.72, and we will get 833.3, well, and that's just repeated. So we'll take the cube root to solve for w here. So the cube root of that is going to give us 9.41. So the width of our box is going to be 9.41 centimeters. Now, what are we asked to find in this question? We are asked to find the cost of building the box. So to do this, we can just use our cost equation here, which is expressed entirely in terms of our width, and just sub in the width that we have found. So our cost is going to be 0.36 times 9.41 squared plus 600 divided by 9.41. And let's work out what that is. I get something like 95.64. So our cost is going to be $95.60. So let's just sum that up. We'll say the cheapest box is $95, sorry, and 64 cents.